12 people died when the roof of this pool collapsed onto the swimmers. The rods holding it up were stainless steel. And the water was not to blame. The air was. If you are an air conditioning expert, you need to know this. An indoor pool is one of the most demanding spaces in all of climate engineering. The water surface evaporates around the clock, and that chemical-laden humidity has to go somewhere. ASHRAE models evaporation with an equation that says three things: more water surface, more evaporation; drier air, more evaporation; and faster air over the surface, more evaporation. Of those three variables, your climate system controls only one: the velocity. That is why air distribution is not a detail. It is the equation. The air must be kept 1 to 2 degrees above the water temperature, relative humidity between 50 and 60%, and the whole room under negative pressure. Every parameter out of range is paid for, in evaporation or in condensation. All that humidity seeks the cold surfaces, the glazing, the frames, and the hidden roof structure. The ASHRAE handbook warns about it verbatim. In the worst case, the roof could collapse because of corrosion from water condensing on the structure. The chlorine that keeps the water safe reacts with what swimmers themselves bring in, sweat and urea, and produces chloramines. The most aggressive is trichloramine. That classic pool smell that stings your eyes is not clean chlorine. It is new chemistry. Trichloramine is denser than air. It piles up exactly where the swimmer breathes. A study published in 2022 measured 1,910 parts per billion right above the water and concluded that code minimum ventilation cannot flush it out. Chlorinated vapors rise, condense on the cold metal of the roof, dry out, and the cycle repeats, concentrating chlorides where nobody ever cleans. The British safety regulator says it plainly: chloramines are the most important factor in stainless steel corrosion in a pool environment. 1985. Uster, Switzerland. The concrete roof of an indoor pool collapsed. 12 people died. The forensic investigation found that the stainless steel rods holding the slab had been cracking for years through chloride-induced stress corrosion. In 2001, in the Netherlands, another pool's false ceiling came down. Air ducts included. Same stainless steel, same corrosion. In 2003, it happened again in Finland. Chlorinated air does not discriminate. It attacks every piece of metal hanging over the water. Engineering believed that corrosion only appeared above 55 degrees Celsius. In pools, it happened at 30, on parts nobody washes. And a duct lives exactly there, right under the roof, in the zone where chlorides concentrate the most. Let's be direct. Galvanized sheet corrodes and ends up dripping rust over the pool. Aluminum pits in chloride atmospheres. Fiberglass absorbs moisture and promotes microbial growth. And the stainless grade that truly resists costs 3 to 4 times more than conventional stainless, and still demands constant inspection. No traditional duct belongs over a swimming pool. A fabric duct changes the problem at its root. Synthetic materials take no part in the electrochemistry of corrosion. At DUCTecoL, we work with a wide range of technical textiles, polyamides, aramids, and other polymers. And depending on the process in each zone, we run a chemical compatibility study before selecting the material. And not just the fabric. The threads, the hooks, and every component of the duct are chosen to withstand that air. And the air distribution is exactly what the handbook calls for. Sweep the glazing with dry air so it never condenses, barely graze the water surface, and diffuse evenly, with no drafts on swimmers. Laser microperforations and calibrated nozzles produce that pattern by design. Fabric weighs roughly 1/10 of the equivalent metal duct. That means far less load hanging from a structure already working in an aggressive environment. And an installation measured in days, not weeks. In total installed cost, freight, mounting, and maintenance, our engineering documents savings between 30 and 70% against metal ductwork. And against the high-grade stainless a pool would truly demand, the difference is even larger. And the maintenance? The duct unzips, comes down, and goes into a wash at 40 degrees. No repainting, no passivation, no crack hunting with a magnifying glass twice a year. Hygiene, on top of that, is audited by washing, something no rigid duct can offer. This is what the solution looks like installed. Fabric duct running above the water, selected for that air, that humidity, and that chemistry, and working exactly as the handbook asks. If you are designing or retrofitting an indoor pool, let's do the engineering together. Thermal load, chemical selection of the fabric, and the air distribution pattern. DUCTecoL, Fabric Duct Engineering.